All right, welcome back to your favorite pre-calculus class. Let's review properties of logarithms for a minute. I want to first remind you about exponential functions, like for example, y equals 2 to the x, which has that horizontal asymptote y equals 0, and its inverse. So if I flipped all those points, instead of 0, 1, I have 1, 0. Instead of y equals 0, I would have the vertical asymptote x equals 0. And if I flipped all those points, and plug in 1 here, it should spit out 0 instead of 0, 1, right? Because it's an inverse. This is log base 2 of x. So we know log base 2 of 1 is 0. Or might I remind you that there is a logarithmic form of a logarithm, right? Here's my logarithmic form, and then there's the exponential form where we go 2 to the y equals 1. Well, we know 2 to the 0 equals 1, so y must be 0. So we know log base 2 of 1 is 0. So that's the first one. Our example, log base 2 of 1 equals 0. So log base 3 of 1 would be 0. Log base 4 of 1 would be 0, and so on, right? Now, because these two are inverses, they undo each other, and they're reflective about the line y equals x. All right, so when I run the composition, log base 2 of 2 to the x, right, when I put 2 to the x in for x and I run its composition, it'll spit out x. So, for example, log base 2 of 2 would be log base 2 of 2 to the 1 would be 1. There's that second one right there. So log base 3 of 3 would be 1. So on. They undo each other. And it goes the other way around as well. If I go 2 to the log base 2 of x, it'll also spit out x. Okay, so 2 to the log base 2 of, let's say, 3 would be 3. So that's that one right there. Fourth one, log base b to the r. Again, they undo each other. That's just r, all right? Log base b to the r. So log base 2 of 2 to the 8, for example. Log base 2 of 2 to the 8 would be 8. Again, they undo each other. Now, these below right here, these are unique to logarithms. The first one is called your power rule, so that r can be thrown in front there. These are unique to logarithms. That's the power rule. Okay. Next one's your product rule. So log base b of m is log base b of m plus log base b of n. So you can split it up from a single logarithm. You can expand it to 2 logarithms. And then the next one is your quotient rule for logarithms. Log base b of m over n has a minus. You can put a minus between those two. Okay. So let's use these properties and find some exact values. Here's our first one. Log base 3 of the 9th root of 3. Well, I'm going to write the 9th root of 3 as 3 to the 1/9. I'm going to put that as in exponential form. And I know that if those are the same thing right there, they're going to it's going to undo each other and just leave you with that 1/9 up there. So log base 3 of 3 to the 1/9, 1/9. Because log base 3 and 3 to the x are inverses. So log base 3 of 3 to the x will just spit out x. Okay. E and the natural log. Let's revisit that. Here's my e to the x. Here's my e to the x. Its inverse is log base e of x. Well, log base e of x was special enough, popped up as scientific phenomena and so on, that we give it a name, the natural log. Log base e of x is the natural log. So e to the ln of x is just x, and ln of e to the x is x. They're going to undo each other. So here we have e to the ln of 6 would just be the 6. E and ln undo each other because they're inverses. So their composite will spit out x. All right, let's go ahead and do these examples now. Notice I have log base 2 of this log base a half of 1/4. I'm going to start with this inside. Let's just take this log base of a half of 1/4. Now, what I know is log base b of b to the r is r. So what I want to do is rewrite that 1/4 as 1/2 to the something. Log base a half. 1/4, isn't 1/4 1/2 squared? Isn't that 1 squared over 2 squared? Right, that's 1/4. So now notice log base a half of a half to the 2 is just 2. So this inside has become 2. So now what I'm solving is log base 2. So what is log base 2 of 2? Log base 2 of 2 to what power is that? Well, it's a power of 1. So log base 2 of 2 to the 1 is just 1. That's our final answer. So our first step was to solve the inside. And then once we get that answer, of course, replace it right there. All right, let's do this next one here. We have 5 to the log base 5 of 6 plus log base 5 of 7. So what I'm going to do here is I'm first going to take this exponent up here. Let me go to the side for a minute. Log base 5 of 6 plus log base 5 of 7. I'm going to use the rule log base b of m plus log base b of n. It will condense into log base b of m times n. So this will become log base 5 of 6 times 7. Or log base 5 of 42. So now let me come back over here, step 2. So I'm going to replace my exponent with log base 5 of 42. And remember, 5 to the x and log base 5 of x are inverses. So 5 to the log base 5 of x is just x. And log base 5 of 5 to the x is x, right? They're inverses, they undo each other. So when I'm looking at log 5 to the log base 5 of 42, it just spits out that 42. They undo each other. Now this one, notice I have a log base 9 of that stuff there, but it's asking us to express it as a sum or difference. In other words, expand it. Some textbooks will say expand the following logarithm, right? So we have log base 9 of x squared times the square root of 3x minus 5. So I'm using those 3 rules up top, right? So I have the log base b of b to the r ends up being, I think, it was an m. Let me use an m as well, sorry. M to the r is r times log base b of m. The next one was the log base b of m times n. Log base b of m plus log base b of n. And then the third rule was m over n. Log base b of m minus log base b of n. Okay, those are again 3 unique to logarithms properties. So I'm going to use this second one right there, and I'm going to expand this. This will be log base 9 of x squared plus log base 9 of the square root of 3x minus 5. Now I'm going to write 3x minus 5 as 3x minus 5 to the 1/2. I'm going to write that in with my exponential notation there. And now I'm going to use the first rule, where I'm going to put that r in front. See how that r can go in front, that power. So I'm going to put that 2 in front. I'm going to put that 1/2 in front. And because we don't want any, we're going to express any powers here as without, with no exponents here as factors. And we're all done. There it is. The original one logarithm is now a sum of two different logarithms, right? We've expanded it. So we're going to do the same thing here. This also wants us to expand it. So our rule, first rule is we're going to use this one right there. Log base b of m over n. Now, the natural log, remember the natural log is the same as log base e, right? So log base e of m over n is the same as the natural log of m over n. So it still follows the same, ln of m minus ln of n. It still follows that same quotient rule, right? Because natural log is log base e. So we'll write it ln of x plus 5 to the 4th minus ln of that bottom, x to the 3rd. And then we'll use that power rule. We'll put that 4 in front. We'll put that 3 in front. And so we got 4 natural log x plus 5 minus 3 natural log of x. So here we've got log base 4 of the top. I'm going to expand this. Log base 4 of the top times the 3rd root of x minus 2 minus, so I'm going to use the quotient rule, log base 4 of that x minus 1 to the 4th. Now what I'm going to do is I'm going to use the product rule on that one. So I've got log base 4 of x minus 5 to the 5th plus log base 4 of the 3rd root of x minus 2. Well, the 3rd root of x minus 2 is x minus 2 to the 1/3. And of course, we still got this minus. And then finally, I'm just going to use that power rule and put that in front, front. And so we've got 5 log base 4 of x minus 5 plus a 3rd log base 4 of x minus 2 minus 4 log base 4 of x minus 1. Well, let's try this one now. Notice that I have natural log of all this stuff to the 1/4. So the first thing I'm going to do is put that 1/4 in front. 1/4 natural log of this stuff. X squared minus 5x plus 6 over x plus 2 quantity cubed. And the second step is then I'll use the quotient rule. So I'll have 1/4. And you know what? Ideally, I would also factor that numerator. Let's go ahead and factor that. So we have x minus 2, x minus 3 over x plus 2 cubed. Okay. And that's so that I can eventually use the product rule on that numerator. But let's go ahead and put the 1/4 there. We're going to use the quotient rule. So I have the natural log at the top. And this 1/4 will go through to everybody as I split this up into ln of the top minus ln of the bottom. All right, so I have ln of the top, ln of the top minus ln of the bottom. 1/4 is on that because that natural log splits into 2, so the 1/4 should be distributed to both of those. Now I'm going to take this one and use my product rule. So I have 1/4 and then that ln x minus 2 plus ln x minus 3 and then minus, and I'm going to go ahead and put that 3 in front, 3 ln x plus 2. And then the 1/4 goes through to everybody. So we've got a 4th ln x minus 2, a 4th ln x minus 3, minus 3/4 ln x plus 2. This would be a great time, you guys, if you want to make this a U-triad problem. Pause the video and scratch that out. So first thing is I would write as log base of the numerator minus log base of the denominator. And then I would go ahead and use the power rule on that. So I got log base 5 of 2 plus log base 5 of that x to the 4th plus log base 5 of that x minus 4. And then minus, now I'm going to expand this, so I'm going to put it all in parentheses. I got log base 5 of 5 plus log base 5 of x minus 3 to the 5th. And again, don't forget that's going to distribute there. I'm also going to go ahead and use the power rule. That goes in front, that's going to go in front. So we have log base 5 of 2 plus 4 log base 5 of x plus log base 5 of x minus 4 minus log base 5 of 5 plus 5 log base 5 of x minus 3. Now notice this log base 5 of 5. Log base 5 of 5 to the 1 is just 1. So this is minus 1 right there. So I got log base 5 of 2 plus 4 log base 5 of x plus log base 5 of x minus 4 minus 1 plus 5 log base 5 of x minus 3. And circle that answer there. And sorry guys, I just noticed I messed up this stupid. I was supposed to distribute that right there. So that's supposed to be a minus right there. That's a minus, sorry about that. All right, now we're going to go the other way. We're going to go ahead and some textbooks will just say condense these into one single algorithm. One single logarithm without negative exponents. So we've got 1/2 log base 6 of x plus 2 log base 6 of x minus 2. So first thing is I'm going to put those exponents up there, back up there. So log base 6 of x to the 1/2 plus log base 6 of x minus 2 squared. And x to the 1/2, I'm going to write that as the square root of x. Now notice I got a plus between them, so I'm going to condense them. That's the product property, and they both have to be the same logarithm. They are both log base 6. So square root of x is going to be multiplied by x minus 2 squared. And so that is one single logarithm. All right, let's condense this one as well into a single logarithm. Now, I'm going to go ahead and put that up as a power first. So I have the natural log of the x squared minus 1 minus the natural log x plus 1. Now it's to the 2. All right. Now, notice I have a minus between them. So this is the quotient rule. So I'll have natural log. That x squared minus 1 will go to the top. The x plus 1 quantity squared will go to the bottom. So I have the natural log of x squared minus 1 over x plus 1 squared. Now be careful on this. Notice I have difference of squares, x minus 1, x plus 1, if I factored that. On the bottom I have x plus 1, x plus 1. Notice that that will simplify. So go ahead and simplify that, x minus 1 over x plus 1. So that's what you end up with here. The natural log of x minus 1 over x plus 1, it can be reduced to that. This next one, we're going to go ahead similarly. Let's take that up. Let's take that up. So we've got log base 3 of x to the negative 2 plus log base 3 of x squared plus 2 minus log base 3 of 4 plus log base 3 of x to the 3rd plus log base 3 of 8. I'm going to write that log base 3 of x to the negative 2 You write that as log base 3 of 1 over x squared. Now notice I got a plus on those, so I'm going to multiply. Log base 3, I got 1 over x squared times x squared plus 2. So that's x squared plus 2 all over x squared. I multiplied those. Let's write the, we'll just take it one by one here. Notice I have a minus now, so I'm going to put log base 3. I got x squared plus 2 over x squared. That's all divided by the 4. And then I have and I want to simplify that. You know, this is 4 over 1, so multiply by the reciprocal. So we've got log base 3 of x squared plus 2 over 4x squared plus log base 3 of x cubed plus log base 3 of 8. So now I'm going to be multiplying and multiplying again. So I got log base 3, I've got x squared plus 2 being multiplied by x cubed being multiplied by 8. This is all over that 4x squared. So I have 8x cubed times x squared plus 2 all over 4x squared. Now I do want to simplify that. Notice the 8x cubed over 4x squared. That'll just leave me with a 2x. So I have log base 3 of 2x times x squared plus 2. All right, now we're going to get into what's called a change of base formula. If you remember on your basic scientific calculator, you have a log key, which is the common logarithm, right? That's log base 10. So you can find the log base 10 of something, some value, let's say 2, right? You could find the log of 2. The other key you have is the natural log, like you could find the natural log of 5. That's the same thing as log base e of 5, by the way, same thing, the natural log, right? So those are the two keys that you have. So how are you going to do log base 5 of 8? Well, you got to use this change of base formula to do that. So that, per the formula, is the exact same thing as log of 8 over log of 5. You can change it to base 10. If you want to put the little 10s in there, you can. And you'd punch it in that way. So log base 5 of 8 is whatever log of 8 over log of 5 ends up being. But you can change it to any base. So another one, since you have the natural log key, you could do ln of 8 over ln of 5. And it'll give you the exact same thing. So let's go ahead and do that on our, if you pull up decimals.com/scientific. All right, here we've got our decimals.com/scientific. I'm going to pull up my log, or I could just punch in log. I'm going to plug in 8. Remember, that's log base 10 divided by, and you can just type in log of 5 if you want as well. You don't even need the parentheses, actually. And you get that 1.29202.967. But I just want to show you that's the same thing as the natural log. You could use the ln of 8 divided by the ln of 5. See how it's the same thing there. All right, so you can change it to log base e, or the natural log. So let's go ahead and punch that in. That was 1.29202.967.4. We're going to round it to 2 decimal places. 1.29. Ditto on that down there, right? 1.29. So let's do another one here. Use the change of base formula to calculate log base 3 of 8 times the log base times log base 8 of 9. Well, we could write that as log of 8 over log of 3. Remember, that's base 10, log base 10 of 8 over log base 10 of 3, times log of 9 over log of 8. And notice my log of 8's cancel. So this actually ends up being log of 9 over log of 3. which, interestingly enough, log of 9 is 3 squared. So I could actually put that 2 in front. 2 times log 3 over log 3. And I end up with 2. That whole thing ends up being 2, right? And you could use a calculator to verify that if you wanted to as well. But this one works out real nicely for you. Well, thanks so much for taking notes. See you next time.